The mysteries of Jupiter and its moons. Could life exist beyond Earth? For centuries, humanity has sought to unravel the secrets of the universe. While people once struggled to grasp the laws of classical physics, 21st century scientists are tackling far more complex challenges. Thanks to their efforts, we now possess an impressive list of discoveries that allow us to peer into the most distant and enigmatic corners of the cosmos. I invite you on a journey to the nearest galaxies. But first, we'll visit Jupiter's moons, discuss future spacecraft, stop by Polaris, leap toward the most extreme exoplanets, and explore the star WR104. An exciting adventure awaits. Let's begin. Conditions for life beyond Earth. The emergence and sustenance of biological life require a combination of factors: liquid water, an energy source, and a diverse array of chemical elements. Beyond Earth, there are several places in our solar system that could harbor life. The prime candidate, of course, is Mars, which has been extensively studied in recent years. However, the chances of finding extraterrestrial life extend beyond its orbit. We need only look closer at the next planet from the Sun. Jupiter. The gas giant Jupiter is the largest planet in the solar system, 318 times more massive than Earth, and is composed primarily of hydrogen and helium. Its atmosphere also contains methane, ammonia, sulfur and nitrogen compounds, and water ice. Despite this chemical diversity, the likelihood of life on Jupiter itself is negligible. The absence of a solid surface, extreme internal temperatures, and crushing pressures in its depths makes survival impossible for any known organisms. Yet Jupiter boasts a vast system of moons. The four largest, Io, Callisto, Ganymede, and Europa, were discovered by Galileo Galilei in 1609. These moons rank among the solar system's largest, rivaling Mercury and Earth's moon in size. Scientists believe Jupiter's gravitational compression during its formation generated immense thermal energy, which it now radiates into space more intensely than it receives from the Sun. This makes Jupiter and its moons resemble a miniature solar system. Subsurface oceans, potential cradles of life at first glance. Jupiter's moons seem inhospitable. They are far from the Sun, ice-covered, and lack substantial atmospheres. Yet closer examination reveals astonishing possibilities. Callisto, Europa, and Ganymede likely harbor liquid oceans beneath their icy shells. Calculations suggest that such subsurface oceans could maintain conditions suitable for life, even at distances where Earth-like planets would freeze. The thick ice crust not only shields against radiation and meteorites, but also acts as insulation. Thus, these hidden oceans might meet the prerequisites for life, making Jupiter's moons prime targets for exploration. Ganymede. The moon with a magnetic field. Ganymede is the largest moon in the solar system, even bigger than Mercury, with a radius of 2,634 kilometers. Its mass, 1.48 times 10 superscript 2 superscript 3 kg, is twice that of Earth's moon. Unique among moons, Ganymede has a liquid iron core and its own magnetosphere. Radioactive decay in its interior provides additional heat. While its surface averages minus 162 degrees Celsius, its core may reach 1,500 to 1,700 degrees Celsius. Data from the Galileo spacecraft suggest a multi-layered saltwater ocean lies beneath 200 kilometers of ice, possibly divided by layers of different salinity and temperature. Ganymede's atmosphere spectroscopy reveals a tenuous oxygen atmosphere, likely produced by UV radiation splitting water ice. Hydrogen escapes into space, leaving oxygen behind. Other detected compounds include carbon dioxide, sulfur dioxide, sulfuric acid salts, organic molecules. These may originate in the subsurface ocean, though their transport mechanism, possibly cryovolcanism, remains unclear. Exploring Jupiter's moons. Despite keen interest, Jupiter's moons have only been studied via flybys. No landings have been attempted, nor are any planned for the upcoming JUICE mission, launching in 2023. However, JUICE will conduct close-range mapping, with results expected by 2034. Callisto. An ancient ice world, Callisto, the outermost Galilean moon, spans 4,821 kilometers, 99% of Mercury's diameter. Its namesake, a nymph from Greek mythology, was transformed into a bear by Zeus. Orbit and rotation, orbiting Jupiter at 1.88 million kilometers. Callisto completes a revolution every 16.7 days. Its rotation is tidally locked. Structure: Callisto's nearly circular orbit minimizes tidal heating. Surface temperatures average minus 103.5 degrees Celsius, and it likely lacks a molten core. Yet Galileo detected a 100 km deep subsurface ocean, possibly containing ammonia to lower its freezing point. Surface: the darkest Galilean moon, reflecting just 20% of sunlight. Callisto is heavily cratered, one of the oldest surfaces in the solar system, for 0.5 billion years. Notable features include Valhalla, a multi-ring impact basin 4,000 kilometers wide. Asgard, a smaller concentric structure 1,600 kilometers. No mountains or volcanoes exist. Erosion has smoothed smaller craters over time. Atmosphere: Callisto's faint atmosphere, primarily CO2, may include traces of O2. Pressure is 1.3 million times weaker than Earth's. Colonization potential: NASA ranked Callisto the top candidate for future bases due to minimal radiation, 7 times lower than Earth. Geologic stability: abundant water ice for fuel and life support. Future missions: upcoming projects include JUICE, ESA, 2023 Ganymede, Callisto, and Europa studies. Europa Clipper, NASA focused on Europa's ocean. EJSM, International, a multi-spacecraft Jupiter system survey. If life is found beneath the ice, it would redefine humanity's place in the universe. We may be on the brink of monumental discoveries.